Let's use vectors to solve an application problem. The magnitude and direction of two forces acting on an object are 250 pounds in the direction of north 60 degrees east and 150 pounds in the direction of south 45 degrees east. Find the magnitude to the nearest pound and the direction angle to the nearest tenth of a degree of the resultant force. Alright, let's look at the first force. It's 250 pounds in the directions of north 60 degrees east, so I've drawn that here. Notice that creates a reference angle in the first quadrant of 30 degrees. So we use these values to represent our force as a vector F1. So we have 250 times a cosine 30 degrees I plus 250 times a sine of 30 degrees J. Now let's look at our second force. It's not as large, so the arrow is shorter. It's 150 pounds in the direction of south 45 degrees east. Now if we look at that as an angle between 0 and 360, that is 315 degrees. And we will use that to write this force as a vector. And that's of the form 150 times a cosine 315 degrees I plus 150 times a sine of 315 degrees J. So we have our vector 1 and vector 2 for our respective forces. Now you can pile this into your calculator, but in essence what's going to happen here, we're going to add the I components, we're going to add the J components, and that will give us the resultant vector F1 plus F2. Now if we approximate this to a couple decimal places, our new vector is going to look something like the following: 322.58 I, and again that's approximate, we're kind of rounding that, plus 18.93 J. And so this is our resultant vector, and you can kind of visualize this as going 322 along the X and then about 19 up, and again that comes from our parallelogram rule that we discussed in a previous example. So let's now look at the magnitude of this, because that's what we're looking for, the magnitude to the nearest pound. So if we take the magnitude of this, we're going to get an approximate value of 323.135, and if we take that to the nearest pound, we get our answer of 323 pounds. Now that we have the resultant vector, let's find the angle of this resultant vector. Alright, so here we have it. F1 plus F2 is approximately, remember we rounded this to a couple decimal places, 322.58 I plus 18.93 J. We have a nice little formula here using the tangent. We know that the tangent of theta is equal to the vertical component, 18.93, divided by the horizontal component, which is 322.58. So if we take the inverse tangent of both sides, the inverse tangent of this nice fraction should give us that angle that we're desiring here. So 322.58. We plug that in there, we're going to get an approximate value of 3.36. And again, make sure your calculator's in degree mode. But we want this now to the nearest tenth of a degree. So to the nearest tenth, we can say that this is equal to 3.4 degrees. And so that completes our problem, solving an application using vectors.